basis of speed breeding is giving the plants a better quality light, a higher intensity light and a longer day length. Speed is important just like in many walks of life, and in this institute there's about 500 scientists who are in a virtual race against time to produce better crops to face tomorrow's challenges. And one of the great limitations we face is growing the plants from seed to seed. If we can do that faster, we can get results faster and produce those crops faster. When everyone in the institute, they heard about the success we'd had, they all wanted to do speed breeding, and we were able to scale up speed breeding into our glass houses. So now effectively we've doubled the capacity of plant growth in the John Innes Centre.
I work within the molecular agronomy programme for Brassica here at the John Innes Centre. We decided that we were going to test speed breeding in some of our brassica plants. So when we're growing brassica napus in the glasshouse, generally it takes us about 9 months to go from seed to seed. Speed breeding allows us to shorten that amount of time so we can get through more generations per year.
I heard about speed breeding some 2.5 years ago from a colleague in the University of Queensland, Lee Hickey.
Behind me you can see literally hundreds of different experimental wheat and barley lines that we've rapidly created in the speed breeding system.
When we first published the speed breeding paper, we had emails from collaborators all over the world who were interested in using it as a tool for their research and/or breeding program. But they didn't have access, some of them didn't have access to expensive growth chambers or big glass houses like we had here in John Innes and also our collaborators in UQ. And so it was important that we develop something that they could quickly buy the parts of from the market very cheaply and then put it together with minimum skill.
As we got more and more ideas, we decided to apply for an open plant, which gave us enough money to produce 3 prototypes.
And the idea is then this technology becomes accessible, it's democratic now. Anybody can set it up on their desk and have a speed breeding system running to get their crosses growing and their research program accelerated. So that was the main idea for the small cabinet.
Well, of course we'd like to go even faster and see if we could get down the generation time to, say, just 6 weeks. Then we would get a theoretical maximum of 9 generations per year. Of course, we always want to go faster if we can. I think we've got a very respectable BMW, but can we turn that into a Ferrari? And can we then one day turn the Ferrari into a spaceship and go even faster?